This is 9,4 beta. And the two things we need to focus on 9,4 beta primarily are absolute and conditional convergence and the ratio test. So we're going to pick up with the PowerPoint. Absolute convergence, what does that mean? Well, ready? It's not the language arts definition of absolutely. It means that the absolute value of the series converge. And if the absolute value converges, then the series converges absolutely. What does that mean? Here's an example. So you've got this, the sine of x, caret n, where n goes from 0 to infinity over n factorial. What does that look like? Well, let's build an H chart first. My H chart would look like this. I start at the 0 term, yes, because that's what's at the bottom substrate. And the 0 term would be sine x to the 0 power over 0 factorial, which equals what? Everyone, it equals 1, yes. Because anything to the 0 power is 1, and 0 factorial is 1. So the first term is a 1. The 0 term is 1. The first term would be what? Sine x, correct. Because it would be sine to the first, yes, over 1 factorial. The second term would be what? Sine squared x over 2. Okay, so the issue is, well, let's not ask you to do that. I want you to build the H charts to understand conceptually what's being asked. It's an organizational tool, okay? Because if you just start like, well, what are they asking? When you read the question, while you're building the H chart, your mind is solving the question. You got to trust your subconscious, it's working on it. But then when you go back to see if it makes sense, you're looking at an organization of what was being asked. So, what about the numerator? Where are they getting that 1 from? What happened here? How can they write this? That this is less than or equal to that? Correct. The sign just oscillates from -1 to 1. So the absolute value of that, the highest it gets is 1. It could be equal to that, or it could be less than 1, which makes that bigger. Which makes that, this thing here is less than that. Yes. This is bigger, because this is 1. This one could be less than 1. So the numerator is smaller. So this would be equal to what's on the right, or less than. Yes? So now what? E to the x, which we showed you yesterday, but yesterday, if you're in front of me, you were at home. This is the comparison test. It's the only one. It's the only non-geometric, I mean constant multiplier, geometric, series that does not have alternating terms you're responsible for. So we compare it to e to the x. What do you got? Converges to E. So therefore, the question converges, not to E, but it converges. Because this thing is bigger than that. This is bigger than that. So if it's above it, that was the PowerPoint, we had the dots. And if the dots are above it, and you know the dots above converge, the dots below have to converge. So that is. But it converges absolutely. Why? Because we use the absolute value. So when you see that vocabulary term, and this will become clear to you when you do the homework talk. When you see the vocabulary term, the distinction, the question AP test will look like this. Does this converge absolutely, conditionally, not at all? Conditionally means the series converges, but its absolute value doesn't. What does that look like? It looks like this. 1 subtract 1/2 plus 1/3 subtract 1/4. That is the alternating harmonic. This converges. What am I getting? Well, these two would give me 1/2. Then I add 1/3 to that, right? And I get 5, 6. Then I take 1/4 from that, yes? This is convergent. But the absolute value, 1 plus 1/2 plus 1/3 plus 1/4 diverges. This is what you saw yesterday. This is the nth term test, which is so dumb. If the terms in the middle column are getting smaller, if the terms in the middle column are getting larger, then it definitely diverges. But if the terms in the middle column are getting smaller, it doesn't guarantee that it converges. See, if it were that easy, anybody would do it. This is saying these terms are getting smaller. This is the middle column of the H chart. They're getting smaller. I'm telling you that this thing diverges. This thing, where the signs alternate, converges. Blue, I know you can't see this at home, but we'll spend time. Blue is the alternating harmonic. Red is the harmonic. Okay? The absolute value of blue does not converge. So therefore we say the blue one converges conditionally. You got to think about that. We'll come back to it. But absolutely and conditionally. If I take the absolute value of the blue terms, the red terms do not converge. So the blue series does not converge absolutely. So what's left with it converges conditionally. And that's kind of a hard thing to get your mind around because you got other stuff going on in this chapter. But they will definitely be multiple choice questions. Okay? And we'll spend time on this on 9.5 because these are famous series. The harmonic series is a famous series. The alternating harmonic are famous. Because this one, the blue one converges and the red one diverges. And we're going to need to use that when we get into 9.5. But they're the ones you lean on when you're thinking about the distinction between absolute convergence and conditional convergence. Right? So the second part of the beta lesson, beta, that's important, is the ratio technique. So what have we got? We got the nth term test, which is a joke. We got direct comparison. But the terms have to be positive, the direct comparison. All. And the only thing you're going to directly compare it to is EVX. The ratio test, and there's an integral test, there's other tests. The ratio test is the one you will see the most. If you want to get your goal on the AP test, you can only understand one thing in this section. It has to be what's coming up now. The ratio test, which is kind of logical, but there's a little bit of algebra involved. So here we go. So if it's geometric, it's not a big deal, because we have a constant multiplier. The issue is, what if it's not geometric? Like geometric, we could teach that in pre-calc. But if it's not geometric, that's where you get a challenge. So here's what happens. So you say, what's the term, the next term? So we compare the nth term to the term above it. And if you get, this happens. The series converges if the number you get's less than 1. Does that make sense? Yeah, because if the number you get's less than 1, then this term, the numerator is bigger than the denominator. Sorry, the numerator is smaller than the denominator. The numerator is smaller than the denominator. If this term is less than 1, the numerator is smaller than the denominator. Yes? If it is the other way around, it diverges. Because the middle column would be getting larger, the H chart. If it's equal to 1, we don't know. It's inconclusive. Here's an example. Now, ready? This thing here, I'm not really asking you to memorize that. That's on page 491 of your book. That was in one of the earlier lessons how they did this. And they did this by differentiating this and putting the derivatives in as the coefficients. That's what's on your quiz on 9.1 and 9.2. So we're not going through that derivation again. We're just saying here. That's how they got ln x. By replacing the x with x take away 1, and those 1s would add to 0. So then you replace each of these x's with x take away 1. Now you notice what's happening? The signs are alternating. And that's what this is saying. You've got this n in the denominator, which is arithmetic. You have x take away 1 to the n. Here is the ratio test. Now think about this. This is kind of awkward how they did this. They skipped a step. You take this, right, and make this the denominator, and replace the n with n plus 1, and you make it the numerator. So you take this negative, this n plus 1, and replace with n plus 1 plus 1. That's where they got this negative 1 to the n plus 2. Then this n is n plus 1, and this n is n plus 1. And then you divide it by this. But dividing it by this, they skipped a step and said multiply by the reciprocal. Personally, I would have written it out. See, this thing is this. You have negative 1 to the n plus 1 times x take away 1 to the n over n. And you're dividing that into negative 1 to the n plus 1 plus 1 over x take away 1 to the n plus 1 over n plus 1. In order to do that, and you divide by a fraction, you invert and multiply. That's what the ratio is tested. Compare the term, the general term, to the term after it. Put the general term in the denominator and the next term in the numerator. We're here. So here's how they wrote this. I don't think that's really helpful. But watch what happens. You have negative 1 to the n plus 2. You just have negative 1. Why? Well, one of these is negative and one's positive. So we're taking the absolute values. So those two just reduce. Make sense? Like if this is negative 1 to the 5th, and that's -1 to the 4th, either way, they're going to give you -1. Either negatives at the top or the bottom. But you're taking the absolute value of the whole thing, so they just reduce. Then what? Then they didn't do anything. Oh, they rewrote this. X take away 1 to the n plus 1. Ready? What happened there? When you add exponents, under what circumstance? When you multiply like bases. So you just undid it and give each of those terms in the exponent their own base of x take away 1. That's the algebra part of it. Why would they do that? Because then these terms would reduce. Is that logical? 100%. Well, how would I know to do it? That's what you're going to do. You're going to do the ratio test. When in doubt, there is a flow chart in the book, which I don't find particularly helpful. Some people do. Some children think the flow chart, helps them. I would just say go to the ratio test. If the clock's running, you're taking the AP test. We're doing chapter 9. Anyone else that converges? Ratio test. So now where are we? Where is Eddie? You're here. You just combine those terms. Now, what's going on here? N's going to infinity. So how did they get x take away 1? 3 syllables, how'd they get it? Ugh. L'Hopitality. It's the limit as n goes to infinity. The derivative of n is 1. The derivative of n plus 1 is a 1. 1 over 1. 1 over 1 times that. So now what? So that's the constant ratio here. Meaning we got rid of the n's because we used limits, concept of limits to do that. And now we have this. Drop the absolute value from -1 to 1. Add 1 to all 3 terms, and you get from 0 to 2. That is the interval of convergence. What is the ratio of convergence, Luke? What did we say yesterday about the ratio, radius of convergence? What's the radius of convergence? Correct. So what would the radius be? Yes. The interval is 0 to 2. The radius is 1. Okay? But if you look back at that question, there's a lot of algebra to get you there. And the point is, it's a multiple choice question, and you would have these choices to choose from. You're not randomly guessing, you got a 25% chance to get it right. You have to be able to do this algebra to get to the answer. And the algebra could be a little intimidating, but when you do some practice problems, you'll see that, this is pretty user-friendly. But this question, look like a mess? Not a big deal. Watch what happens. Where are they getting that? That's what the series is. That's the middle term of the H chart. The first term's a 1, so they put a 1 in for n. 1 over 3 the first, times what's in the parentheses to the first, and then so on. Yes? These are the terms of that series. How do we do the ratio test? We take this thing here. We put it in the denominator. Well, putting it in the denominator is the same as, and this is what's awkward on the PowerPoint. They skip that step. So they just put the reciprocal here. Ready? 3 to the n is in the top, and n times x take away 5 to the n is in the bottom. This thing here is the reciprocal of the general term. Why is it the reciprocal? Because during the ratio of the n plus 1 term to the n term. And the way to divide by a term is by inverting and multiplying. But if you were, I don't know, like trying to look at this PowerPoint independently, I think you would get stuck between those two lines. Where'd that come from? You might be, if you didn't get stuck, that'd be awesome. Now what? This is the next term. So take all the n's and replace them with n plus 1. Yes? And then you're doing this thing right here on the left, divided by the general term, which is written as times the reciprocal of the general term, and we want the absolute value of that. So what happened? Same thing. The last one, they broke this 3 to the n plus 1 into 3 to the n times 3. Everything else I just wrote across. The only thing that happened between this line and this line is property of exponents. With us? They reduce. They reduce. Enough with that. Good? What are you going to do? They didn't even write this last slide, right? You can do that. N going to infinity has something to do with x plus a negative 5. That's going to 1/3, L'Hopital. 1/3, yes? L'Hopital times that. See it? That's got to be less than 1 for it to converge. Work this out. It's the limit as n goes to infinity. That'd be infinity over infinity, which is indeterminate. So you can apply L'Hopital. The derivative with respect to n would be 1 plus 0. With respect to n would be a 3. You're there. This whole thing has got to be, the absolute value is going to be less than 1. Multiply both sides by 3. Add 5 across the inequality, and you get 2 to 8. Now here's the issue. See, once you do a few problems, this isn't that hard. Yes? But please tell me this. If you're not following what's going on here, Eddie, get your head up. You need to go to the nurse, go ahead, I'll tell you, right outside the cafeteria. If you look at this question, don't tell me you're going to guess the answer is 2 to 8. There's 4 choices there. That's not going to appear to you the logical to go from this to 2 to 8. You need to use the ratio test. And what you're seeing is you're going to see a problem just like that. Multiple choice, 2 minutes to do it. And they're not going to tell you to use the ratio test. You're going to have to say, if there is numerical convergence, that is the most likely way to do it. Overwhelmingly. What's the radius of convergence, Eddie? No. I didn't ask you to read what's on the screen. What's the radius? Okay, so there are more examples on the PowerPoint. We're not going to keep going. We're going to go to the PDF. But you could say, okay, well, here's where we are. He's on slide 15. He only went through the first 14 slides. So I'm going to go through slides 15, 16, and 17 to help me. On Wednesday, my reading day. Nope, I'm not doing that on Wednesday because I'm focused on the chapter 10 text. Okay, do it on Saturday. Cool. Clock's running. This is April, okay? We don't take Saturdays off. So we can do this problem now. Which of the following gives the radius of convergence? Here's the question. I'm telling you, this is the ratio test. Okay? 2 minutes. Use the ratio test on this question. Now, so I wrote this out. Does that make sense? I wrote this out, which they didn't do on the PowerPoint, that is this term, the question, the n plus 1. Then you invert and multiply. Here's what happens. This has to be less than 1. Drop the absolute value symbol. I'm doing reverse order of operations. Add 3 across. Divide by 2. And you would get from 1 to 2. So the radius is 1/2, which the answer is C. Okay? Now, this was kind of, once you get some practice with this, this is kind of transparent. Why? Because they're both A's. So you go right to that. You're not ready to see that yet? You could. All right. Now, we are going to complete the PDF or continue the PDF in the building. If you're at home, you're going to have to come back to the PDF tomorrow. And you're welcome to bring any questions to AP Launch on Thursday. But if you're at home, you're dismissed to go to AP Classroom right now to do the exit ticket. So here's a problem. Here's the way I wrote it out. This is example 4. This to this. Invert and multiply. This thing where I said multiply by 1/n, that's the same thing as L'Hopital. Okay, so the radius, the interval's from -10 to 10, the radius we have for that, that's 10. So that's up there. That's your model for you to go to problem number 19. So I'm just going to say for the recording that we're not going to have time to go over 19. So you're just going to look on the PDF for problem number 19. Okay.